Hello, everybody. So today we're moving on to dividing polynomials, and then we're going to take a look at remainder and factor theorems because they all go together. So what we're going to do in this lesson is that we're going to look at long division, synthetic division, then we're going to use the remainder theorem to evaluate, and then we're going to use the factor theorem to solve a polynomial equation. So let's start with long division. So long division has a bunch of steps to it. So before we actually do this, let's take a look at what if I was to give you 37 divided into 2,400. Ooh, no, let's not do that one. Let's do 4,722. And I asked you to long divide this. So when you long divide, you take this piece here, and you start with the first number. How many times does 37 go into 4? It doesn't. So then you go to the next piece. Well, how many times does 37 go into 47? It goes in one time. 1 times 37 is 37, and it's positive. But when it comes under the little house here, because I call this a little house, you take that 37, it becomes a negative. So then we subtract, and we wind up with 10, and then we drop down the next number. So what I'm really looking at is 102. So now 102 is bigger than 37, so we do it again. We say, how many times does 37 go into 102? Well, we know that 37 times 1 is 37. 37 times 2 is 74. 37 times 3 is 112. So it can't be 3, so it has to be 2. So 2 times 37 is 74. It's positive, but as it comes under, it becomes negative. We're going to subtract, so that gives me an 8. That goes to a 9, that gives me 28, and then I drop down my next number, which is a 2. Then I ask myself, how many times does 37 go into 282? And I do the process all over again. 37 times 3 was 112, times 4 is 148, times 5 is 185, times 6. So 6, that gives me 222 times 7. So 7 is 21, it's 259. And then if I go times 8, I wind up with more. So I have to go to 7, multiply that out. That gives me 259, but remember when it comes under, it needs to become negative. That gives me a 3. And then that winds up with a 2. The 23 is smaller than a 37, and I have nothing else to bring down. So I have a remainder of 23. So that's how you used to be able to do long division with just straight numbers. That whole entire process. Multiply, change the sign, subtract, bring down. Multiply, change the sign, subtract, bring down. It's going to be the same thing here, except we're going to be looking at polynomials. So the first thing you're going to do, if it's not already, we need to arrange the terms both for the dividend and the divisor in descending power. Now, here's the catch with this one. If you were missing a power, so let's say it starts off with x to the third and then it goes minus 2x. Well, you missed that x squared piece, so you have to put that that placeholder in there. So since that x squared is not represented, you have to add 0x squared because you need to have that placeholder in there. And that's true for both of them. So make sure that when you're arranging terms in descending power, you need to make sure that all variables are represented. So then you go through to the next step, and we're going to divide the first term by the first term of the divisor. So we have the dividend and the divisor. Once we figure out how many times that piece goes into that first term, we put that up top, make sure it lines up with the appropriate variable, and then we multiply every term in the divisor by the first term in the quotient. And then we are going to subtract. So basically it's the same thing. So we multiply, change the sign of everything, and then subtract. Once we do that, we bring down the next term or terms, because you could have to bring down multiple terms. And basically we're going to start all over. We're going to keep doing this process over and over until you can't. Okay? So this is just a process that you keep doing over and over and over again, so you can make sure that you have everything lined up where it needs to go. You know you're done when the degree of the remainder is less than the degree of the divisor. So if it's ever equal to, you have to keep going. If it's ever greater, you have to keep going. But once that remainder winds up with an exponent that's less than your divisor, then you can stop. That's your remainder. Stop, bring down anything else if you need to, and you're done. So let's actually walk through a couple of these. So we're going to divide 7 minus 11x minus 3x squared plus 2x cubed by x minus 3. So the first thing we need to do is arrange everything in descending order and make sure that there's nothing missing. So the x minus 3 has nothing missing. And then the 2x cubed minus 3x squared plus 11x plus 7, that's all there as well. So now that I have that set up, now I start. So I have a focus. I only care about this right here. This is what drives this whole entire problem. So I'm going to start this here. How many times does it go into this term right here? And I usually keep track of this off to the side. So I come over here and say 2x cubed, and I'm going to divide that by x, and I wind up with 2x squared. So that 2x squared is going to go above this x squared here. And now I'm going to multiply and change the sign. So if it was positive, it becomes negative, and if it's negative, it becomes positive. Because the goal is, once I focus on this piece, I need to get rid of it. That's what this is going to do. This is going to get rid of that, okay? So 2x squared times x gives me a positive 2x cubed. So as it comes under, it's going to change a sign and becomes negative 2x cubed. X squared times, 2x squared times negative 3 is a negative 6x squared, but as it comes under, it becomes a positive 6x squared. Now we combine. If you did it correctly, that goes away. So I've got 3x squared negative, that's going to be added to a 6x squared. So when that happens, I get a 3x squared that's positive, and then I drop down my next term. Now I have a new focus. My new focus is this term right here. So now we're going to do it all over again. So I'm going to say that 3x squared, divide that by my focus that's right here. That winds up with 3x. So this 3x is going to go right here, and since it's a positive, I put the plus sign in front of it. And then again, I multiply, change the sign. So 3x times x gives me positive 3x squared, but as it comes under, it becomes negative. 3x times negative 3 gives me a negative 9x, but as it comes over, it becomes a positive 9x. If you've done everything correctly, that cancels. You're left with a negative 2x, and you drop down the next term. And then we do it again. Okay. So my new focus again is I've got a negative 2x all over an x. That winds up with a negative 2. Multiply it, change the sign. Negative 2 times x gives me negative 2x. So as it comes under, I get a positive 2x. Negative 2 times negative 3 is a positive 6, but as it comes over, it gives me a negative 6. Those go away. That leaves me with a positive 1. That 1 is less than the x over here, so there's nothing else I can do with it. So then I have to write my answer out. So I write my answer by taking what's written up here. So I have 2x squared plus 3x minus 2, and then plus this piece right here, 1, divided by this piece right here, x minus 3. And I am done. That is my answer. Okay. So when you're finished with everything, you take this top piece, which is that, and then you add it to this number divided by that divisor. Okay. And this is how you long divide a polynomial. So let's try it again. So 3x squared minus 2x, we're going to divide this into 6x to the 4th plus 5x cubed. Notice I probably at the original problem didn't have an x squared, so I had to put in a placeholder. So plus 0x squared plus 3x minus 5. So again, the same thing. This is my focus. So I'm going to start right here. So then I come back over here and say, okay, I've got 6x to the 4th all over 3x squared. That gives me 2x squared. So I put that 2x squared right there. I'm going to multiply everything through. That gives me a negative, so it becomes a positive 4x cubed. That goes away, leaving me with a 9x cubed. And I drop down my 0x squared. I have a new focus, which is this one right here. So I wind up with 9x cubed divided by 3x squared. And that winds up with 3x. So that goes here. Multiply, change your sign. So that gives me a positive 6x squared. That goes away. Bring down my next term. Again, I've got a new focus. So then I have 6x squared divided by 3x squared. That gives me a 2. So that winds up with a negative 6x squared here and a positive, 4x here. That goes away. That leaves me with the 7x, and I drop down my next term. This is now a lower degree of that, so there's nothing else I can do. So I write my final answer, which is 2x squared plus 3x plus 2 plus 7x minus 5 all over 3x squared minus 2x. Okay? So let's try one more. So I've got this one set up and ready to go for you. All I need you to do is go through and divide. Show me how that remainder goes over the divisor at the very end if there is one. So go ahead and hit your pause button now. All right, welcome back. Let's see how you did. So if you did that, that's hopefully what you got, which means your work looks something like that. So notice your focus all the way through is there and there, and then there, and then there. Oops, not there. I missed. No, that's right. That's right. Then I went all the way through And then at the very end, I put my remainder over my divisor, and I'm done. And that is long division. So now, let's look at synthetic division. So synthetic division is a little easier. The nice thing about synthetic division is it once you get the hang of it, it goes really fast. The key is though, you can only use, so put a note somewhere. You can only use when dividing by x minus whatever. Okay. If this is 3x minus whatever, you have to use long division. But if you have this and it's in this form of x minus or x plus, as long as it's in that format, you can use synthetic division. And like I said, you can factor these really quick once you can do that. But if this had been 3x minus 2, you can't do it. If it was 4x plus 5, you can't do it. If it's x plus 7, you can do that one. Okay? So this same thing is going to apply. Range of polynomial in descending powers. So we start back that again with 0 coefficient for any missing terms. Write C for the divisor of x minus c, so whatever your C is. So we want to make sure, basically, you're going to solve that linear. And then what's going to happen is you're going to put that on the right and then write the coefficients of the dividend. So this has an actual setup that we're actually going to go through. And then what's going to happen is you're going to write the leading coefficient on the bottom row, multiply that, write the product in the next column, and then you're going to wind up combining in that new column and writing the sum of whatever you combined on that bottom row, and then you're going to repeat. And then so what's going to happen is once you get everything filled out, you're going to have a bunch of numbers. So you actually have to write out your answer. So you're going to use the numbers in the last row to write your quotient plus the remainder above the divisor. So here's the key right here. The degree of the first term of the quotient will always be 1 less than the degree of the first term of the dividend. So if you started out with an x to the 5th, your answer will start out x to the 4th. That's what that's saying. So I know this is a bunch of rules and stuff, so let's actually go through and walk through a problem together. Because like I said, this is extremely easy. And so when you actually see how it works or whatever, it makes a whole lot of sense. So use synthetic division to divide x cubed minus 7x minus 6. So this is what it's asking you to do. So the first thing we need to do is we need to take this x plus 2 over here, and we need to solve that make that equal to 0. So we need to solve that. That's where this number comes from. And then you have your actual problem here. That number is going to go right there. So when you're actually taking a look at this stuff, you're going to go through here and then you're going to wind up putting answers and everything else down here as well. So you're going to drop the first thing, your answer will go here, and you've got a lot of multiplying and dividing up here. So let's actually walk this problem. So this is how it works. So once you have it set up correctly, you're going to drop this first number down here like this. And you say -2 times 1, that's a -2. And then you're going to combine these two together. Oops. So -2 minus 0. I'm sorry. 0 minus 2 gives me a -2. Then I'm going to start it again. -2 times -2 is a +4. Combine these two together, I get a -3. -2 times -3 is a +6. Combine these together, and I wind up with a 0. So you notice once you get to this little box right here, you're done. This box right here, this is your remainder. Okay. So if you have a 0, that 0 means that this is an actual factor of the problem. So then I take my remainder, I take everything that I've got written right here. Now we're going to rewrite. So if you remember, this is written in this format right here, x to the third. So that means that this right here is going to start off with an x squared. So I wind up with x squared minus 2x minus 3. And I do not have a remainder. So that is my answer. If it asks you to factor it further, then you just use your factoring skills that you've learned in the past and you factor this down further, and then you'll be done. So if I'm looking at this, x squared minus 2x minus 3 becomes x minus 3 and x plus 1. Okay? So let's try this again. So again, you're looking at this. I need to set this up. So I'm going to take that x plus 2 over here, and I'm going to say x plus 2, set that equal to 0. I get x is equal to negative 2. That negative 2 goes right here. And then I'm going to take this, I'm going to write each one of my coefficients. Notice that my x squared is missing. So I got to make sure that gets represented by a 0 because it has to be there. Oh, let me space that out better. So I've got a 5, a 0, and a 6. Okay? And then I just go through the process. That gives me a negative 10, and then I combine. That gives me a positive 20, and then I combine. And that gives me negative 52, and then I combine. And then I write my answer. So remember, this starts off with an x cubed, so that means that this is going to be an x squared. So I have 5x squared minus 10x plus 26 plus a negative 44 all over x plus 2. And this would be my final answer. Okay? And that is synthetic division. It's a very straightforward process. Like I said, it'll be fast and quick, especially once you do more problems with it or whatever. And it's a really quick way, if you're ever dividing by a linear equation, to be able to go through here and see, if it's factorable or not. Okay. So now, remainder theorem. So remainder theorem uses synthetic division. So what's going to happen is you're going to get a problem, and it wants to know what's the remainder at a specific number. So when you go through the process, I'm going to go back here. Whatever number you get right here is going to be what's called the remainder theorem, is going to be what the y value is at that x coordinate that's right here. So since this is not a 0, this means that when x is negative 2, my y is going to be negative 44. So you're going to do this same thing. You're given they're going to give you a problem, and notice here they have this piece set up right here. You're going to use your synthetic division. Now this is already here for you, so you're literally just going to write that right there. Put your numbers into your synthetic division setup, and then start your synthetic division. 32 minus 5 is 27. That is 108 with a negative, so that's negative 105. So it's saying when x is negative 4, my y value is going to be negative 105. And that is what the remainder theorem does. So it evaluates the polynomial at that specific number using synthetic division. Okay? So take a moment, hit the pause button, and try this. And go. All right. Welcome back. So let's see how you did. Oops. Almost wrote the wrong number there. So we've got a 2. It's a -2. It's a -4. That's a 1. That's a 2. And that's a 5. So you should wind up with a 2, 5. And, if you're not sure, you have this thing called a handy-dandy calculator that mine always asks me to set this up, which I don't understand why. It shouldn't, but whatever. That's the story of my life. So you come over here and you say x cubed minus 4x squared. Oh, I hit the squared button. Plus 5x plus 3. Hit my graph button. It's going to do the math magic and graph it. And then you hit trace, type in 2. And there it is. There's your 5. So that's all it's asking you to do. Okay. And that is your remainder theorem. Pretty simple. So let's look at our final theorem then. The factor theorem. So the factor theorem basically says if you go through the whole synthetic division process and you wind up with a 0 in the box, then you have a 0 at that specific number. Basically, it crosses the x-axis at that number. Your graph does. So that's what the factor theorem says. It wants you to, when you do the synthetic division, so I'm going to go back. When you do synthetic division, factor theorem says this needs to be a 0 in order to say that this right here is a factor of this problem here. That's what we're looking for. And we looked at that a couple of slides ago right here. Notice how we had a remainder of 0 here. So this -2 is an actual factor of this actual problem. So that's what we're looking at on that, okay? So let's take a look. So it wants you to solve the equation given that -1 is a 0 of this. So you're going to set this up and do your synthetic division. So I have everything here. I go through and notice how it says that this is a factor. So now it wants me to continue factoring this. So as I continue factoring this, this is what I wind up with. So I take this piece right here and I need to factor this down even more. So using your quadratic skills, you can use your quadratic formula or whatever else. But I'm going to factor by grouping. So I need factors of 30 that subtract to give me a -1. That's going to be a 5 and 6. So I rewrite it, my -1, into this terminology right here. Then I'm going to factor the front and factor the back. And then I'm going to rewrite my leftovers. So my leftovers are here, this piece right there. And then that is what we started off with. So if you remember, that's what we were dividing by right here. You have to remember that's x is equal to -1. So when I move that back over, that becomes x plus 1. And so that is where this blue x plus 1 comes from. So this means that our original equation here, this piece right here, when we factor this down, it factors into 5x minus 2 times 3x plus 1 times x plus 1. Okay? Let's try it one more time. Solve the equation of f of x equals blah, given that 3 is a 0. So what it's saying is that x is equal to 3, which means for later on, I have x minus 3 is equal to 0. So that's one of my factors we're hoping. Stick the 3 here. 2, -3, -11, and a 6. So that gives me a 6. That gives me a 3. That gives me a 9. That gives me a -2. That gives me a -6. And that gives me a 0. Hey, that worked, which is exactly what we wanted. So I know I have my x, what was it? Yeah. have my x minus 3 as one of my factors, and then 2x squared plus 3x minus 2. So then I need to factor this down. So I need basically factors of 4 that subtract to give me a 3. That's going to be a 4 and a 1. So over here off to the side, I have 2x squared plus 4x minus 1x minus 2. Split this in half. This gives me a 2x, x plus 2. I'm going to pull out a negative 1 so I can get my x plus 2. Combine things back over. So that means when I completely factor this, I have x minus 3, 2x minus 1, and x plus 2. Those are my factors for this, okay? So just remember when you're using the factor theorem, this is a non-negotiable. This has to be 0. And if it's not a 0, you cannot use the factor theorem. You have to have a 0 in that box right there. Okay? All right. That is it for this section. Let me know if you have any questions. Send me a text, send me a remind, whatever else. And I guess you can start homework now. Hope you have a great day. I will see you soon. Talk to you soon. TTFN. Ta-ta for now.